Great. Okay. Just before so the Institute for Automated Language Teaching and Assessment is it is important to Cambridge because Cambridge University has Cambridge University Press. You may know their textbooks, and also Cambridge Assessment. They recently, in the last year, have joined as one company. And Cambridge Assessment, a very large part of it is it's all about exams. And a large part of that is actually exams for people learning English, such as IELTS or First Certificate of English or LinguaSkill. And we basically work as ourselves in the computer science department, working on machine learning and natural language processing, speech processing approaches to automatically assess and give feedback for learners of English as a second language. The work I'm going to present today is in fact, most of it's not my work. It's the main contributors to today's work are Professor Mark Gales. So sorry, I couldn't be here. A lot of the work has been done during her PhD, which she's recently submitted by Edie Liu. And also some of the work has been done by Stefano Bano, who actually visited us from Fondazione Bruno Kessler in Italy, where he's a PhD student. But also, over the years, we've had a number of members of the project team, and obviously, many have contributed to the work. So today I'm going to talk about, first I'll talk a bit about what do we mean and how do we do automated language teaching and assessment. Then I'll talk about what spoken grammatical error correction is and how we can build systems for that, and then look a bit at how we can use that in assessment and feedback. And finally, some of the challenges that are left from a research perspective. So computer-assisted language learning and assessment has had huge growth in the last few years. You know, with the growth of the internet, with the availability of data, with everybody having small devices, people would like to practice outside class or in class. Sort of, you know, they want to be able to do this 24/7. And we can use the data, we can use GPUs to build new models and get better. I believe it's something like Duolingo has, something like 2 million, was it 20 million? It's a massive number of billions of users just in the UK alone learning languages. So not all of the, I know this is not a comprehensive set. What's interesting is that not all of these, quite a few of these don't have speaking. When you look at the speaking component, it might be, oh, here's a video of what you'll need to do for the speaking, but a lot of them don't have interaction, but increasingly they do. And so that's where we're going. In ourselves, in LinguaSkill and Upskill are two exams that Cambridge has developed. Where we have LinguaSkill is hybrid marked. So this is taking technology that we've developed in Outer and is automatically marking the speaking. And then if the system is uncertain, a human will sort of do a further mark. And Upskill is a fully automated system, so completely auto-marked. It's based in India. And we also have Speak and Improve, which is a practice application for research that anybody can just register and try out. So why such a growth and why is this important? Well, the British Council estimates that there's nearly 2 billion people worldwide who are using or learning English as a second language, whether that's for university, for work purposes, or just because they want to. I want to watch that latest Hollywood movie without the subtitle. And also that means, 2 billion people, there's not really enough teachers or examiners to verify that you've got to that level that you want to be at. And so automated assistants and computer-aided language learning systems have a real role to play here to help support people in their learning experience. And some of that's also maybe directly to the learners, but also for teachers to help them teach a class and support that. And increasingly, we were seeing moving towards data-driven, what's called integrated learning and assessment. So effectively, this is what teachers already have been doing. You see how every so often you do a test for your class, you see how well people are doing, you realize what have they not picked up, do they need more work on their pronunciation, or they can't confuse in plurals and single things, and then you teach them that module, and then you retest and so on. But we're getting towards a stage where we can do this using technology to deliver, sort of automatically deliver personalized learning. So it'll test you every so often. So that might be you can use as evidence of how good you're doing, but it'll also help you see where you need to improve and deliver you to the right learning modules. Obviously, we're at a speech conference, so speaking is what we're interested in. And it is, obviously it's a key skill for communication. And many speakers, though, many automatic systems heavily restrict the speech input. So if they have speech, it'll often be read this sentence. And that's very good, especially for the lower level of learner. That's very good at looking at how well somebody's pronouncing, but it's not really testing communication. And for that, we really need to have free speaking, where I can speak as I'm speaking now, quite freely. So it's going to be spontaneous. It's going to have all the issues of conversational speech. And then there's two sort of sides. There's the sort of monologic side, where giving a presentation, single speaker. There's also dialogic, of course, where you actually are having a conversation with somebody, with one or more people. And the work I'm going to talk about today is primarily focusing on monologic speech, just because at the moment we kind of know how to do that, and conversational that's one of our big research challenges. So let's just remind ourselves. So but what we're working with is L2 learner speech data. In fact, with the data we have goes from very beginner levels of English, where people can maybe go to a hotel and say, I have a reservation, or go to a bar and, get some beers, all the way up to people who are basically fluent. I mean, in fact, if you read the information about what you need to get the highest level, you need to be more fluent than a native speaker. And it's very challenging. This is actually a annotation of somebody's actual speech. They're a reasonable level. I mean, they're talking quite a lot, a reasonable level. So in this free speaking, the person has a minute to talk. And so this is what they've said in a minute, and then there's corrections. And we can see a number of things here. One is that of course, it's free speech. So how are you going to know what somebody said? We don't have a transcript to look at. So we need to run speech recognition. And as we all know, speech recognition is not perfect. Well, imagine, I'm sure you've all tried Alexa or Cortana, etc. And you know that when you're asking for something with a foreign name, or you're speaking, it's not great at accented speech. And learners, we have some very low levels of learners, so the pronunciation isn't standard. It's not native speakers. It's and the grammar is not going to be quite the same as a native. So all these things that make speech recognition harder. Well, I just went, this is, we all do it. It's quite natural. As you're speaking spontaneously, you hesitate, you so that will occur naturally. We also, we're disfluent when we speak naturally. We start a sentence, realize we wanted to say something else. So that's in there as well. And the other thing is, of course, there's no punctuation, there's no sentences. In fact, we don't really necessarily even speak in sentences. except if you're sort of, a newsreader or something like that. So it's very challenging. And then finally, of course, we don't always just, speech is a very rich communication medium. It's not just what you've said, it's also how you say it. So it is the prosody. What are the, if I say, oh, please close the door, please close the door, I'm expressing a very quite different message in the second case. So how can we assess that, and what's up the general pipeline? So this is sort of fairly standard approach used by people. So you have the speaker will maybe they'll receive a question prompt, and they maybe talk for typically some questions short ones, 10, 20 seconds. Others, maybe they can talk up to a minute. I've seen some tests people have 2 minutes. And there may or may not be speech processing to convert the audio into some sort of features. And then the audio gets passed to a grader to automatically mark it. And that grade can then be passed with the same features to a feedback thing. So we get graders going to give you a score. We also tend to have a confidence score. So it's how confident is the grader that it's actually given. I had one the other day where somebody got, they said, oh, you're C2, the highest level. They are an English speaker, but the confidence was 0%. And it was correct. They should not have been, at that time, they shouldn't have been graded. So they'd given only 2 words. So. But we can then also use that information to feedback to the user how they're doing in their performance. And there's 2 kinds of feedback that people do or can think about doing. And one we call analytic feedback. And this is typically, this would be like a holistic feedback over all your speech. So some sort of idea of how fluently did you speak? How clearly was it? What was your use of vocabulary? But nothing, you're sort of looking as a whole, sort of commenting as a whole. And then the other kind of feedback is the more fine-grained feedback. So this might be on a per word basis. This word was mispronounced, or this phrase, you might want to look at this phrase. I'm not sure the grammar is correct there. And so when we come to assess this, the approach that's taken, we obviously when the examiners, when they build the construct for assessment, there are sort of 5 core skills within the speaking area. And the first thing, when you say you're assessing or working with people learning a language, the first thing that comes to everybody's mind is pronunciation. Oh, what's my pronunciation? And of course, it's not just pronunciation. It's not just the phonetic sequence. It's also the prosody, the rhythm, the duration, intonation. And also, as I mentioned, obviously hesitation, and when you're given an exam, there's that thing of how much do people use the time available? So if I'm given a minute and I only say 2 words, I've not really made use of the time that's available. And so we can think of these 2 aspects as really realizing the message. So we've got some message to convey to somebody. When you're talking, you've got some message to convey. Actually turning that message into an audio signal, these 2 aspects. And those are in many ways the things that people are the easiest things and the things that people have focused on in assessing and feedback. The slightly harder task when you're dealing with free speaking, because you've this question of what are people actually saying, is the aspects related to the message construction. So what is the actual message that you're trying to get over to people? And so we look at things like how coherent is the message? Did it achieve the task? Have you actually responded to the question? So if I'm asking you to talk about giving a presentation at a conference, I don't expect you to come and start talking about the fact that Argentina are through to the final of the World Cup football. And the other main aspect, and the one we're going to focus on today, is what they call language resource. And language resource is quite a simple thing. It's your grammar and your vocabulary usage. So we know as your English proficiency or whatever language you're learning, proficiency goes up, so will your range of grammar that you use, the range of vocabulary, and also the accuracy of those aspects. And why does this matter? Why is this an important thing to assess and also encourage people to learn and help them learn? Well, the better my grammar is, the more accurate I am. I can better communicate my ideas. You know, people get, if the grammar isn't right, or I really don't know how to say something, I don't have the words, which is always my problem. People ask me, can I speak Chinese? I think I know one word, and my Japanese is very much at a beginner level. It's often, so I can't communicate my ideas. So it's very important. And if I can't communicate my ideas, I can't achieve the task that I set out to do. Now, obviously, in writing, they have the language, they know what was said, and so it's used a lot in writing to both assess performance level, but also as a tool to give feedback. So a lot of writing systems, assessment systems, are actually based on grammatical errors, and there's a lot of grammatical error corrections. So they will look for where are the mistakes in the grammar, both at the word level and at a sentence level. In terms of speaking, we haven't really used it too much to date. Our graders tend to look at holistic proficiency. So we consider all these 5 aspects as a whole. But recently, people have started to use grammatical accuracy we'll talk about some of the work for using it as an additional feature in the holistic training. But also we introduced some work earlier this year that we did, which is the idea of how can we make it more explainable and interpretable, our assessment, so we can give more precise feedback? So we can break as I said, the message construction and message realization into individual components, and can we try and grade each one separately, each aspect separately, and then combine them to give a score? And so the particular use for grammar is what I'll talk about in this talk. Okay, so spoken grammatical error correction. So just grammatical error corrections. So the aim is to produce a grammatically correct sentence given a sentence with mistakes. So in the original case here, the cat sit on the mat. So the verb there, sit, is incorrect. So the correction would be the cat sat on the mat. But of course, it's also perfectly valid to say the cat is sitting on the mat. And this is one thing with grammatical errors or grammar. There is necessarily no right answer. There are multiple right answers, I guess you could say. But it does, in practice, this one-to-one assumption of output has a relatively small effect on using grammatical error correction. For text, there are actually I guess if you use Microsoft Word, it'll correct your English, suggest it's quite annoying at times. I don't want a comma there, but there are systems out there that already tell you how to correct your English, and that's basically underlying that is a grammatical error correction system. And then there's also a lot so that will obviously mostly be trained on first language text, but there's also quite a lot of annotated learner writing that can be used to fine tune these large pre-trained models. The question is, can we apply? So that's fine, it's great, but does it apply to speech? And The thing is there are some challenges to assess and give feedback on grammatical errors in speech. We don't speak in sentences. We repeat ourselves, we hesitate, we mumble. And we also, there's no really defined speech grammar as such. So what our sort of interpretation of speech grammar is effectively phrases that a native L1 speaker is highly unlikely to say. So one of my students the other day was saying, how much experiment should I run? And a native speaker just wouldn't say that. It's how many experiments. It's a very small thing. I can still understand, but it's just that subtle difference. On the other hand, speech does have some advantages. There's no spelling or punctuation errors, whereas we find that over 25% of written texts have these errors. And we also provide additional information about the meaning of the text within the audio signal. So perhaps we can use that to help us. So it's quite clear that spoken text is not written text. So we do need to take that into account when we're doing our work. And so in this case, we might have something like, instead, the cat says sit on the mat, and then to correction. Okay, so what are the challenges for automatic spoken gag? So obviously, as I was saying, ASR errors are likely. So one of the first things we're going to have to do is convert the audio into some text. And this may be unrecoverable. So if the ASR has said see here, obviously it's going to naturally convert it into another verb tense of the verb to see and not the verb to sit. And as we said, this is increased for learner speech because it's harder to recognize. And if we have a stream of speech, we don't have that segmented. We don't have the punctuation to guide us as to where the sentences are. So we have to automatically segment it. And then lastly, which is obviously for machine learning a big problem, is there's a lack of training data. So there's very little annotated speech data out there, certainly very insufficient to train on. There was a Japanese learners of English corpus released by NICT, but that actually doesn't come with audio samples. So for most people, you can do some evaluation, but not the audio. And we're lucky in that we have a proprietary set called Linguists based on this test, Linguists Who Are Speaking. But at the moment, we're only really up to about 3,000 responses. And there is millions of written data, but it is mismatched to speaking. There's no disfluencies. There's a stricter grammar, and it's a different style. Writing a letter versus, tell me about what you see in the picture. They're quite different styles. So as I present the stuff, you think about, what do we require if we're going to build automated systems to assess and feedback? What are we going to require? So in terms of accuracy, we want to emphasize precision. It's probably much, much worse to give somebody feedback on an error that they didn't actually make than to give. It'd be probably better not to give any feedback at all than to say, oh, you made this error. And I didn't make that error. So we want accuracy. We want to try and be as precise, but obviously we would also quite like to have a reasonable recall rate. We want something that is interpretable or explainable, so we can let the learner know not just this was the error, but maybe help them to learn what they did was incorrect. Why was that incorrect? And we also want to have a reasonable computational load and time. For a lot of examination scenarios, we don't need to work in real time generally, but if somebody's doing an app on their phone, obviously we need to give it back in near real time if we can. So let's look at some systems that we've built. So Jenny mentioned about end-to-end systems, very big and popular. Can we use them? Could we just take in the speech and give out the grammatically correct, fluent text? unfortunately, the lack of data that we have just makes this not feasible right now. So these are the data that we typically work with. So we have a lot of training data for speech recognition. So we have audio and text, which is learner speech, but there's no disfluency, there's no grammatical error markers. For disfluency training, the switchboard corpus is still incredibly good. But again, well, that doesn't have grammatical error markers, and it is native first language. And then for grammatical error correction, there's been a number of corpora, like the Cambridge Learner Corpora, the BEA Corpora, released, but they're text and they don't have audio or disfluencies. So instead, we need to rely on a sort of cascaded pipeline. So we build modules where we're going to have the first thing we'll do is run speech recognition. Once we've got the speech recognition, we're going to do disfluency detection, and then we can post-process the audio, the speech, the ASR transcript to take out the disfluencies and pass that to, because they kind of mask what's actually going on in terms of the grammar, and then we pass that to a GEC system to grammatically correct fluent text. And the advantage of this is we can fine-tune each model on different data sets, and there's various sources of information that we can give back to feedback. There are some challenges, though. Firstly, there's error propagation. So any errors that we make in the speech recognition are going to keep propagating. Similarly, the disfluency will propagate into the GEC. There's this domain mismatch if we're training. So the GEC, if it's trained on text, we might have some sort of aspects that are in speech. So some casual speech that it just doesn't know about. And lastly, there's potentially we've provided information through our prosody. And so it could be here, I feel well, pretty bad. Well, maybe the well is with the pretty bad, as the disfluency detection has said, but maybe I was like, I feel well, pretty bad. So it should have changed, and maybe it doesn't. So our ASR system is just a standard hybrid TDNF model with language model trained on the transcriptions primarily, and we're using RNN. So we've got speech from L2 speech from over 25 L1s. In fact, there's about 75 first languages. So and one of the things that we do is we explicitly model partial words and we map all our hesitations to a single token. We want these, unlike a system that's transcribing your text for a text message or something. We want all these nasty things because they tell us how fluently you're speaking. They actually provide us with information on your English ability. And the last thing that we actually use the confidence scores from ASR for many different things in the downstream tasks. Are you speaking English, for a start, is actually quite detectable based on ASR confidence scores. And this is actually one of the reasons why we've not switched so far. We've done some work internally on end-to-end models, but the neural networks tend to be overconfident. And so we've done some work, taken some of the work did at Google, Pijali, on confidence estimation modules, but it's still not as good as a hybrid case. So there's still a place for hybrid systems. So disfluencies. So a typical disfluency, you might have, I want to taxi to Marina May, or I mean to Sentosa. So there's two aspects there. There's a interregnum region. So these are the sort of the filler words, these are where you're hesitating, and they're pretty easy to detect. We can just use rule-based methods to remove those. So it's more detecting when somebody has made a repair, and that's the focus of automatic disfluency detection. So what we typically do is we use a sequence tagging model where basically every word in a sequence is mapped to some sort of disfluency label, which is just, it's okay, or there was an error. And we can do this by using some non-autoregressive taggers, where basically each disfluency label is assumed to be independent of context. So we're just predicting for each word what was given the whole word sequence. We can just predict independently whether it's correct or incorrect. And what we find is that the performance largely depends on the quality of the tagger's internal feature representations. And I'm going to talk about a couple of approaches that are generally used. And what we found is that it depends a little which one's better, depends a little bit on the training criteria and the framework for training. So if we're just taking each module separately, the more complex model is better. But if we're trying to do some sort of joint optimization over the cascade, the less complex is actually performs slightly better. So sequence tagging models, so we can use an RNN, so that gives reasonable, so it's like a bidirectional LSTM, or we can use something like BERT, which gives good high quality feature representation. So just sort of standard techniques. GEC, GEC, you can see, so we're now trying to translate we're trying to detect the words that are wrong. So again, it's a one-to-one map, well, not necessarily one-to-one, but given the output, we want to detect which words are wrong. So it is a one-to-one mapping. And you can see basically it's a bit like a translation problem. You're translating from the correct sentence, the errorful sentence into a corrected sentence. And so people have primarily used it as a sort of sequence-to-sequence machine translation type problem. So using encoder-decoder architectures like the T5 transformer. And so there's one called Gramformer, which is takes the T5 model and explicitly adds in the GEC domain. And then just in the last month or so, OpenAI have released ChatGPT, which is a sort of generative, autoregressive large language model. There's also recently from Grammarly, also some people in India, there's saying, well, let's not do that. Let's actually treat it as a sequence tagging problem. And so here we, instead of trying to figure out what it's mapped to, you actually map it to errors. You say these are the errors, and it tells you what you should change and the classes. And they actually found it was best to do an iterative process. So this is an encoder, and so basically they then try and classify, and so they do maybe 4 times round. And we'll see how they all progress. They're basically working around the same at the moment. So a little bit about how we're getting on in working. So you'll see that this is our text training data for the GEC. We have a lot of training data. This is all text. And for testing, much smaller amounts of actual labeled data. I realize I'm running very behind time, so I do apologize. One of the things we have to do to our training data is we have to pre-process it. So we take the written data and we speechify it. So we remove any spelling errors, remove punctuation, make it so it's like ASR. So we, in our case, we uppercase it. So we sort of take the text and convert it into this format before we run our speech grammatical error correction. So I'm going to give some results. There's about 3,000 sentences from about 340 speakers. I was going to talk about transcription, but I'm going to skip that. But basically, what they do is we pass to the GEC annotators. We pass them a cleaned up text. So everything's been stripped out. They get the manually corrected text. And then what they do is they mark a sort of minimal edit disk correction. They're not marking the specific error that was made. They're not saying the verb tense was wrong. What they're saying, they're just saying this is what you should have said. So public accommodations, public facilities.